Bismillahirrahmanirrahim and Assalamu alaikum to you all. On the behalf of DHA Education System, I welcome you all in my physics class today. Today's topic is about electromagnetic spectrum, and today we will discuss in this topic about dispersion of light. So let's start it. The objectives of today's lesson are: number one, by the end of the lesson, students will be able to describe the dispersion of light as illustrated by the action on light of a glass prism. And the second objective is state the colors of the spectrum and explain how the colors are related to frequency and wavelength. Now the question is, what is dispersion? If we discuss about dispersion, you have seen in our daily life that whenever the light enters through a prism or a corner of a glass window, you have seen some colors that is formed when the white light is split up into different colors. So the process by which the splitting up of a white light into its 7 constituent colors on passing through a transparent medium like glass prism is called dispersion of light. So what it means, when a white light enters to any medium which has a refractive index, for example the glass prism, then it may split up into its constituent colors. And how many constituent colors of white light are there? 7 in number. So you have seen these colored lines, there are 7: red, orange, yellow, green, blue, indigo, and violet. What is the cause of dispersion? Actually, the dispersion of white light occurs because colors of white light travel at different speeds through the glass prism. Because every optical medium has a different optical density. The amount of refraction depends on the speed of colored light in the glass. Now, since the different colors travel at different speeds, so they are refracted by different angles on passing through the glass prism. So when white light consisting of 7 colors fall on a glass prism, each color in it is refracted by a different angle, with the result that 7 colors spread out to form a spectrum. So basically it means that dispersion depends on the wavelength. How it depends on the wavelength? Every color has its own frequency and wavelength. Dispersion occurs whenever there is a process that changes the direction of light in a manner that depends on wavelength. Basically it's refraction. So greater the wavelength of a color, less it will bend in a medium, and smaller the wavelength, more it will bend. And remember, students, that red color has the maximum wavelength in the visible spectrum, and violet has the minimum. So violet bends most and the red least. If you see in this diagram, it's a simple diagram of a spectrum formed by a white light, that the red bends the least because it has a maximum wavelength, but violet bends the most because it has the minimum wavelength. So what is spectrum? The band of 7 colors formed on a white screen when a beam of light is passed through a glass prism is called spectrum of white light. The 7 colors of the spectrum are violet, indigo, blue, green, yellow, orange, and red. And you can easily remember it by the word waveguide. And you have to remember it because in many questions in the paper, it comes that what color comes after the yellow, or what comes before green, or you have to write sometimes the whole sequence of colors of this spectrum. So you have to learn the whole sequence by simple word waveguide: violet, indigo, blue, green, yellow, orange, and red. Let's see a video so that your concepts becomes more clear about this topic.
Check out this ray of light. When it enters a new medium like water, its path will bend, and the larger the index of refraction of the new medium, the more the light will bend from its initial direction that it had in the air. This follows from Snell's law, since if the index of refraction is larger, the angle of the refracted light must be smaller, and in order to have a smaller angle from the normal line, the light ray has to bend more from its initial direction. But here's the interesting thing. When you send in white light composed of all visible wavelengths, the colors will disperse and get separated from each other. We call this separation of light dispersion. So why does dispersion happen? The reason for dispersion is that the index of refraction for water and most other materials are actually a function of the wavelength of the light. For instance, if you ask a physicist or look up the index of refraction of water, most sources would say the index of refraction of water is 1.33. But what those sources or physicists really mean is that the index of refraction is pretty much 1.33 for the entire visible range of wavelengths. However, each visible wavelength has a slightly different index of refraction in water. The index of refraction of red light in water is about 1.33, but the index of refraction of blue light is closer to about 1.34. In fact, for most materials, the smaller the wavelength of the light, the larger the index of refraction, which means smaller wavelength light will bend more than larger wavelength light will in most materials. This is why in water, the violet light would bend the most since it has the smallest wavelength for visible light. Blue light would bend slightly less, green light a little less, yellow light a little less than that, orange light even less, and red light would bend the least. So remember, dispersion and the rainbow patterns that emerge result from the fact that most materials have an index of refraction that's a function of the wavelength of the light. And in most materials, the smaller the wavelength, the more the light will bend.
So I hope so you have understood well by this video also that more the wavelength of the color has, the less it will bend, and the less the wavelength of the color has, the more it will bend, and it all depends on the index of refraction also. So there is an experiment related about the dispersion of light done by a scientist, that Newton's. So it's called as Newton's experiment. Newton performed an experiment actually to show that white light consists of different colors. When a white ray is allowed to pass through a prism to split it into the colors of the spectrum, the different colored light is allowed to pass through an identical prism kept in inverted position. The light emerging out of second prism was found to be white, indicating that the light ray consisting of different colors. See this diagram carefully. This is Newton's experiment, that when white light is allowed to enter through the first prism, then due to the process of dispersion, and basically white light consists of 7 colors. Every color has its own wavelength. So due to difference in the wavelength and index of refraction while passing through the prism, it is dispersed into the 7 colors. It will form a color spectrum. And when this colored spectrum is allowed to pass through a second prism, which is in inverted position to the previous one, then again we obtain a white light. So what this experiment shows actually, that white light first shows dispersion, and when an inverted prism is there, it will recombine again to form a white light, and you will see on a white light on a screen in the output. So what this experiment says that the white light consists of 7 constituent colors, which you have to remember by the word waveguide. So what is the nature of the spectrum and emerging out? That the nature of spectrum emerging out of the second prism, which is inverted, white light is obtained, and the 7 colors of visible spectrum combine to form white light. Now there is a natural spectrum, and every one of us really knows about it. That is about rainbow. What is a rainbow? It's a natural spectrum appearing in the sky after a rainstorm. It is caused by the dispersion of light by tiny water droplets present in the atmosphere. A rainbow is always formed in a direction opposite to that of sun. You can see rainbow when you are facing the sun. The water droplets acts like a small prism. Because prism is a transparent medium, the water droplets are also transparent. The prism has high optical density as compared to air. The water droplets also have a high density as compared to air. So both of them can be assumed to have the same function. So they refract and disperse the incident sunlight, then reflect it internally, and finally refract again when it comes out of the raindrop. Now you have to understand this line. First, the light refract inside the raindrop and then disperse the incident sunlight, then reflect it internally. So after dispersion, there will be total internal reflection, as we have discussed it earlier, in the rain droplet. And finally, it refracted again when it comes out of the raindrop. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. So you can see in this diagram, there are water droplets. So sun's light first enter into the droplet. A little part of it is reflected and the most part is refracted. When it is refracted, as sunlight consists of white light, due to the process of dispersion, it's separated or split into 7 of its constituent colors. Now, the incident ray has angle more than the critical angle, definitely, when we draw the normal here. When this angle is greater than critical angle, the angle of reflection will also be equal to angle of incidence. So TIR will occur here, and after total internal reflection, and after total internal reflection, the rays will refract again when they come out of the rain droplet, and you will see a rain. The picture is more clear here. The sunlight entering it, there is total internal reflection, there is dispersion also seen by this, and you will see the rainbow the 7 colors coming out of the raindrop by the process of dispersion of light. So which component deviates most? Minimum. The minimum is definitely red color. Red color we have discussed has the maximum speed, or you can say also has the maximum wavelength. The maximum the wavelength, the maximum the speed. So the red color is deviated the minimum. And if we take the speed as constant, then red color has maximum wavelength, so it will deviate the minimum. We can see that in this in this diagram, that when sunlight enters the prism, the red colors deviate less, minimum. But which color deviate most? That is violet. So the relationship, now we are going to discuss the relationship between the frequency and wavelength, as every color has its own frequency and wavelength, and we have discussed this equation previously in last 2 lectures, and we are going to discuss that how they are related to each other. What is frequency? Frequency is actually the number of waves passing through a certain point in 1 second or in a unit time. And wavelength is actually the length of a wave or distance covered by the wave in 1 second. So the wavelength and frequency, they are related by this equation. C is equal to F lambda, or you can say V is equal to F lambda, where C is the speed of light. This symbol lambda is the wavelength in meters, and F is the frequency in cycles per second. Now, if we take the speed of light, we take it as constant in air or in vacuum. If it is constant, then we can see that the F will come here on the other side as 1 over F. So you can say that lambda is equal to 1 over F, means they have indirect relationship. If wavelength increases, the frequency decreases. If wavelength decreases, the frequency increases. So so let's discuss some most common questions about dispersion. Of course, after what is dispersion of light and how it is caused, the most common questions we have discussed, that it is caused due to the different wavelengths and frequencies of every color. Every color has its own frequency and wavelength. Red has the maximum wavelength, so it will deviate less and refract, you can say, or it bends less as compared to violet, which has a minimum wavelength. So which color has the highest frequency? For the highest frequency, it must have the smallest wavelength. So violet has the highest frequency and smallest wavelength. When it comes to visible light, the highest frequency color, which is violet, has also the most energy. Here frequency means the energy. The more the frequency of the light color, the more the energy it has. The lowest frequency of visible light, which is red, has the least energy. The next most common question is, which color has the maximum wavelength? Of course, we know that red color has the maximum wavelength and it has minimum frequency, of course. As the full spectrum of white light travels through a prism, the wavelengths separate into the colors of the rainbow because of each color is a different wavelength. Violet has the shortest wavelength. Always remember, this question came many times in the paper, the part of a question, that violet has which color has the shortest wavelength, that is violet, and which color has the maximum wavelength, that is red. And their values are, violet's wavelength value is around 380 nanometers, and red has the longest wavelength at around 700 nanometers. See this diagram carefully. As we know that refraction is responsible for dispersion in rainbows and many other situations, The angle of refraction depends on the index of refraction. We know that the index of refraction n depends on the medium, but for a given medium n also depends on the wavelength. What it means, for the process of dispersion and refraction, it also depends on the wavelength as well as the index of refraction. Index of refraction means that how much refraction occurs in that medium. The higher the density of the medium, more the bending of light, and more will be the index of refraction. As we have discussed in previous lessons, that diamond, among many materials, diamond has the maximum density, and after that another material. But we consider in general that diamond has the maximum density as compared to water and glass. This violet light is bent more than red light as shown for a prism, and the light is dispersed into the same sequence of wavelength as seen in figure. If the incident light is not a white light, there will be just refraction because of the index of refraction of light. But when the incident light is white light, after passing through the prism, it will, by the process of refraction, and every color has its own wavelength and frequency, it will disperse into its 7 constituent colors. And always remember, in many questions, questions related to dispersion, it is asked that which color is at the top of the spectrum on the screen and which color is on the bottom of the screen. On the top of the screen, the color is red, and on the bottom of the screen, the color is violet. And you have to remember again this spectrum by the word Vibgyor, Vibgyor. Let's discuss electromagnetic spectrum a little, and then we will discuss in detail in the next week lesson. Electromagnetic spectrum is actually a spectrum which contains the visible light and the non-visible light also. That if we discuss it and by the decreasing wavelength, as every color or every radiation has its own wavelength. So let's start it with the decreasing wavelength means increasing frequency. As we have discussed earlier, that wavelength and frequency, they have indirect relationship with each other. They are not, if one quantity is increasing, the other must decrease. So if the wavelength is decreasing, as you can see from radio waves, it's 10 raised to power 3, and then from micro 10 is -2, then -5, -6, -8, -10, then -12. So the wavelength is decreasing, but we see the frequency. The frequency is increasing from 10 raised to power 4 to 10 raised to power 20. What this electromagnetic spectrum shows us, that the greater the wavelength, we have discussed the length of the wave. Here you have seen a larger wave and it's moving continuously. Its length, its distance between the two consecutive wavefronts is going to be less. So the wavelength is decreasing. Whenever the wavelength is decreasing, the frequency is increasing. So the electromagnetic spectrum consists of these waves, and you have to learn them in sequence. You can find out any sentence for remembering it. For example, rabbits meet in very unique, expensive, you can say from G, you can decide any other word. You have to remember the sequence, that is radio waves first in decreasing the wavelength. Radio waves comes in the first. After radio waves, microwaves, then infrared. And in between the spectrum, there is a visible spectrum we have discussed that consists of Vibgyor. This is a visible spectrum. And all other radiations are invisible to us. Then is ultraviolet rays, X-rays, and gamma rays. Now, one thing should be clear to you. Infra means before and ultra means after. Before the visible spectrum, it comes infrared waves, and after visible spectrum, it comes ultraviolet. So among them, if a question can be asked from you, that in the electromagnetic spectrum, which radiation has a maximum wavelength? So radio waves have the maximum wavelength. Now here the question is different. They're not asking about visible spectrum. Now they are asking about electromagnetic spectrum, the broad spectrum which consists of all electric and magnetic exposures of the spectrum. So radio waves have the maximum wavelength and gamma rays have the minimum wavelength. So we can say radio waves have the highest frequency. That's why radio waves are used for mainly for the purpose of communication, long distance communications, because they have high frequency and larger wave. And then comes the gamma rays. They have the least frequency. The gamma rays, they have the highest frequency but the shorter wavelength. We can also see from this diagram that how the frequency and the wavelength, they're related to each other diagrammatically. We have discussed that relationship between frequency and wavelength, they have inverse relationship. If the wavelength is more, the frequency will be less. If the frequency is more, the wavelength will be less. So higher the frequency of the wave, the more number of waves passing through a point in 1 second. You can see that there is a distance between two consecutive points in phase, that is wavelength, is short as compared to a low frequency waves, and it has longer wavelength. So as a part of relation, all the parts of electromagnetic spectrum travel at the same speed. Here we are not only talking about visible spectrum, now we are talking about the whole electromagnetic spectrum. And remember, it's the property of electromagnetic spectrum, and we've also discussed in the next week's lesson that all the electromagnetic waves travel at the same speed, that is with the speed of light, 3 into 10 raised by 8 meter per second. So if the speed is going to be constant, then it means that wavelength and frequency, by the equation V is equal to F lambda, frequency and wavelength, they have indirect relationship. We have discussed it. This means that as one characteristic increases, the other decreases. In other words, wavelength increases and frequency decreases. Now here's a question for you. You have to choose appropriate words to fill the gaps in the paragraph below. If your concept is very clear, then this is a very easy question. Dash occurs when white light is split into a dash by the process of refraction. So that is, dispersion occurs when white light is split up into a spectrum of colors by the process of refraction. In glass, violet light travels more dash than the other colors. So it is deviated the, yes, violet travels more. As you have seen in the spectrum, the violet color is at the last. So it has the more speed than the other colors. So it is deviated. Sorry, it has more speed. So it is deviated the most. The spectrum consists of red. Now here you have to write all the colors of wave choir. Red, orange, yellow, green, blue, indigo, and violet. A dash is formed when water causes dispersion. A spectrum is formed when water causes dispersion. There is another structure question for you. You have to clear it for your application of the concepts related to frequency and wavelength of dispersion of light. What is the frequency of violet light, with wavelength 400 nanometer? Now you have to find the frequency of violet light while the wavelength is given, and nano means 10 raised to power minus 9. So all of us are very well aware of the value of speed of light. You can write C is equal to 3 into 10 raised by 8 meter per second, or the more exact value is 2.998 into 10 raised by 8 meter per second. And wavelength is 400 nanometer. I have told you nano means 10 raised by minus 9. It's a prefix used here. So when you divide these two values by using the equation C is equal to V lambda, then we will get the frequency 7.50 into 10 raised to power 14 hertz. So let's give a quick recap of the whole topic. White light is a mixture. We have discussed in the start that white light is a mixture of all the wavelengths of the visible spectrum. The individual wavelength appears when light refracts through a medium such as glass. This occurs as each color refracts at a different angle. Violet refracts the most and red refracts the least, because violet has a minimum wavelength but red has the maximum wavelength. Another point we have discussed about it, that the frequency and wavelength, they have indirect relationship. When the wavelength is more, the frequency is less, and when the wavelength is less, the frequency is more. As red color has the maximum wavelength, so its frequency is less as compared to violet. So thank you so much, students, for being patient and understanding this lesson wholeheartedly. Take care of yourselves. Allah Hafiz.